So hopefully this will be the last video for 9.3. We're going to go through those two applications I was addressing in the end of the last video, which is one, finding a direction theta associated with a particular vector, and then number two, scaling a vector to be a specific magnitude. So quickly run through this again. Vector v is 2, 3. So for practice, let's write it in ij notation. So it could be written as 2i plus 3j. Or we're going to write it in that cosine sine notation right here. So this component right here is 3, and it is represented as the sine of theta. And this component right here is written as the cosine of theta. And this has been scaled up times a scaled up version of the vector. So here's this little blue one right here. We're imagining that this little part right here is the unit circle vector. There's our unit vector. And then it's been scaled up, or this guy's been scaled down, so that I'm only looking at this blue. So let's look at this little blue guy right here. This blue guy right here would actually terminate on the unit circle. So this length right here is the cosine of theta. This length right here is the sine of theta. So in order to scale this little blue side up to be 3 right here, I have to scale this side right here by the magnitude of v. And then if I want to scale this little blue side right here to be 2, I need to scale it by the magnitude of u. So the magnitude of u, I'm sorry, I keep saying u, but it's v. The magnitude of v here is 2 squared plus 3 squared, which is 13, and I'm going to square root that. So root 13 represents the magnitude of that vector. Okay, so if I multiply 3 over root 13 by root 13, that's going to give me 3. And if I multiply 2 over root 13 by root 13, that's going to give me that 2. So my cosine of theta scaled by the magnitude gives me this length. Sine of theta squared by the multiplied by the magnitude gives me this length. So vector v right here can be written as root 13, which is the magnitude, times the cosine of theta, I, horizontal, plus root 13 sine theta j. Sometimes this is also written with this term right here factored out, so it may also be written more like this. Root 13 times the quantity cosine theta I plus sine theta j. And then when we do these kinds of, we'll use this notation a lot when we do complex numbers and that kind of thing, and getting all of this writing right here becomes condensed to some quick little notes. But for now, we actually have to write it all the way out. So if I'm interested in theta, this pink angle right here, I know that the tangent of theta is this side divided by this side. So the tangent of theta is 3 over 2. I could also say that the tangent of theta is this length right here, which is root 13 times sine of theta over root 13 cosine theta, which makes sense because sine divided by cosine is tangent. So when I simplify root 13s away, I'm just left with sine over cosine equals tangent. So if I'm going to go ahead and solve for theta, then I would go ahead and take the tan inverse, or the inverse tangent, of 3 over 2 is the theta I'm interested in. And you can use your calculator to come up with that value. Okay. Let's do a rule here real quick. So if I have some vector u sub 1, u sub 2, or u sub 1i plus u sub 2j, I can rewrite that as, there's my imaginary unit circle down in here, that I have whatever the magnitude of u is times cosine cosine of theta, whatever the magnitude of u is times sine of theta. So you can always write a vector like that. Nothing new. Which means that the tangent can always be written as u sub 2 over u sub 1, or the sine of theta over the cosine of theta. Two, this is a reference back to that very first rule we looked at in this section, the rule from page 1 in our notes, which is that if I have some vector and I scale it down to make it a unit vector, I can scale it back up to be any size I'm interested in. So I make a unit vector and then I scale it up to be a specific size, and I've got what I want. So we're going to quick run through an example, and then I'm going to have you do one for practice before you come back tomorrow, so you're ready to ask questions. So let's say I have vector w here. W is 3i minus 4j, so 3i minus 4j. And I'm interested in determining what theta is. And then I want to scale my vector to be 9 units long. And then if there are any other notations, I'd like to make a second to refresh myself. What does that look like? So I'm just going to, for fun, do this one first. W equals whatever the magnitude is of W times cosine theta I plus sine theta j. 3, 4, and then, oh, surprise, it's a 3, 4, 5 triangle. Thank you, Miss Henderson, for making life easy. So square root of 25 is our magnitude, which is 5. So let's determine theta, or the angle of the vector. So you want to be careful with this, because even though we're going to be solving for this little, let's call it phi or something like that, or alpha, or whatever you want to do. Theta would be the measure of our turn to get to this vector, so let's not forget that. So we're actually going to be solving for theta. So theta is this whole turn, and this angle in here, we're going to call it alpha, something to make our lives easier. Okay, so 3, 4, 5, so we're going to do tangent of theta of opposite over adjacent 4/3, and grab my calculator. Let's say tangent 45 really quick. I'm in degree mode, so my answer is going to be providing me answers in degree mode. So I'm going to do, I didn't mean to do that, escape. Let's go and do tan inverse of 4/3. So the tan inverse, the inverse tangent of 4/3 is theta. Okay, so that means we're going to round to the nearest whole degree here. We're going to say 53 degrees approximately is, oops, alpha. Okay. So if alpha is 53 degrees, then what is the actual direction of the vector? Well, there's a couple of things I can say here. So I can be tricky and say that it's negative 53 degrees equals theta, because that would have been a backwards turn of 53 degrees for this specific answer. It's kind of a tricky little way of doing it. Or I can say that it's 53 degrees short of a full rotation of 360. So I could also say that 360 minus 53 equals theta, which would be that 307 is also theta. So some books will look for answers that are here, and other books will provide answers that are here. So just be aware that those are two answers that may fit this particular vector. Okay. I would like you to do the same thing for this one right here. So you're going to find the other notation, which is that cosine sine notation, and then you're going to find the theta. Okay. So the last thing I want you to do here is scale to 9 units. So my original vector was 5 units long. So I'm going to scale it down. I do that by simply putting it over the magnitude. So W over the magnitude of W. That would be the unit vector for that guy. And if I want to scale him up to be 9 long, then I'm going to multiply by 9 over 1 to each of my components. So 3 times 9 over 1 becomes 27 over 5 would be my x component. And then 9 times 4 would give us negative 36 over 5. So this vector right here would have a magnitude of 5, yet have the same direction as vector W. So you're also going to do that for you. So you'll have 3 things. Determine theta, scale it to 9 units, and then note that other notation, the cosine sine notation. And this is for tomorrow. Have a great evening. We'll see you tomorrow.